Okay, for the last lesson, we're going to take a look at a special type of geometric series, which is called an infinite geometric series, where we know that it's going to go on and on and on and on forever. So there actually is no ending point to this series. We can have two types of infinite geometric series. We can have a convergent one. To converge on something means to approach it. So an infinite series is convergent if the sequence of the partial sums approaches a certain number. So it's getting closer and closer and closer to a specific number. This is always going to happen if the value of r is a proper fraction between -1 and +1. And then we can see that when it's being graphed out, it's going to get closer and closer and closer and closer to hitting one exact point. Just like how we saw with our asymptotes. The sum of an infinite series can be solved by saying it's going to be the first term divided by 1 minus the ratio. If an infinite series is divergent, that means that it's not going to approach a fixed value, so the number is either going to get bigger and bigger and bigger or smaller and smaller and smaller every single time. That happens if r is less than -1 or greater than 1. The infinite series is divergent and has no exact sum, so the formula doesn't work if it's divergent. So first, we're going to take a look and predict whether each infinite series has a sum, is convergent, or if it is divergent by calculating the first few partial sums. So, in this case, if I had 16 plus 8 plus 4 plus 2, well, the first one is just going to be 16. If I add 8 to that, I'm going to get 24. If I add 4 to that, I'm going to get 28. If I add 2 to that, I'm going to get 30. And because the number is changing by a smaller and smaller and smaller amount, if I graphed this, it would look like it started out getting bigger and then is getting smaller as we go through. This is going to be convergent. For the second set, the sum of the first one is just going to be 1 over 2 or 0.5. If I add 1 to that, the first 2 is going to be 3 over 2 or 1.5. If I add 2 to that, the first 3 is going to be 7 over 2 or 3.5. And if I add 4 to that, the sum of the first 4 is going to be 15 over 2 or 7.5. If I was to graph this out, the number would start small and then be getting a little bigger and then bigger and then bigger, and we can see that this is not converging. It's going to shoot off right into the atmosphere. This is divergent. The sums are not getting closer to one specific number. If I'm calculating whether it converges or diverges, remember, in order for it to converge, the ratio has to be between -1 and +1. So I can always check that by solving the ratio. The ratio for the first one would be -9 over 27, which would be -1 over 3 or -0.3 repeater. This is going to converge. So I'm going to use my infinite formula and say that the sum to infinity, or the infinite sum, is the first term divided by 1 minus the common ratio. If I added to infinity, it's going to be 20.25. For the second one, if I said the ratio is equal to negative 8 divided by 4, the ratio is going to be negative 2. And in this case, the ratio is less than negative 1. This diverges. For example 3, in the first month, an oil well in Manitoba produced 36,000 barrels of crude oil. Every month after that, it produced 95% of the previous month's production. If we're listing the series of terms that represents the number of barrels produced in each month, well, I started out with 36,000. And then the next month we added 95% of that, which would be 34,200. And then the next month we added another 95% of that, which would be 32,490. And then it's just going to get smaller and smaller and smaller. If this trend continues, what will be the lifetime production of this well? Well, my infinite sum is going to be that original amount that I was making divided by 1 minus the ratio is 95% or 0.95. How much oil will this well produce? 720,000 barrels. For example 4, the sum of an infinite geometric series is 92 and the ratio is 0.25. What is the fourth term in the series? Well, I can use this sum and the ratio to solve for what the first term is. I'm going to say that the sum of, and this is an incorrect number. That should be a 96 for this to work. The sum is 96 is equal to the first term divided by 1 minus 0.25, which means that 96 is going to equal the first term divided by 0.75, or 128 is going to be my first term. If 128 is my first term, then term 4 is going to equal my first term multiplied by my ratio to the power of 4 minus 1. My fourth term is going to be 2. Given the following infinite series, 5 plus 5x plus 5x squared plus 5x to the power of 3 going on into infinity, which has a sum of 4, determine the value of x and state the restriction. Well, every single time I move from one to the next, I'm multiplying by x again, which means that x is my ratio. So if I know that the first term is 5 and the sum is 4, then the infinite sum of 4 is going to equal the first term, 5, divided by 1 minus the ratio of x. When I multiply the denominator out, I get 4 times 1 minus x is going to equal 5. Which means that 4 minus minus 4x is going to equal 5. Negative 4x, when I subtract 4 from both sides, is going to equal 1. Or x is going to equal negative 1 over 4. In this case, what is my restriction? Well, I know that the denominator can't equal 0, which means that x cannot equal positive 1.